Lesson 3.3, solving quadratics by completing the square. Before we can get to completing the square, we need to talk about what are perfect square trinomials. So we are used to trinomials that have this kind of generic notation, right? Our a times x squared plus b times x plus a constant c. And then we usually say, well, they're equal to 0. So a perfect square trinomial, be on the lookout when you are factoring for a perfect square being in your C term. Okay? So if you have a perfect square as your C value, you may be able to factor using that concept of perfect square. So if we have a perfect square trinomial, we can use these two formulas here to factor them. To me, the formulas are a little intimidating. So I just look for a perfect square in that C term. So let's look at some examples and we'll get through these. So I have x squared plus 14x plus 49. Here in that C term, I have a perfect square. So when I do my trinomial factoring, right, what multiplies to 49? Well, the first one that comes to my head is 7 times 7. And those do add to the 14 that I have here as my b value. Because these two numbers are the same, this is a perfect square trinomial on the left side, right? So what I can do is basically say this is equal to x plus 7 times x plus 7 equals 64, right? Because these two factored terms, these two binomials here, are the same, I can rewrite those as x plus 7 squared equals 64. So this is a perfect square trinomial on the left. And now I can work to solve this, right? So using order of operations for solving, I know I need to move away this squared on the left side. So to undo a square, right, it's going to be square root. So I have x plus 7 equals square root of 64. Right? I can simplify square root of 64 into plus or minus 8. Okay, at this point I need to split the problem into 2 because I have that plus or minus on the right side. Always remember when solving that when you do the square root, it can be plus or minus. So I have x plus 7 equals 8, x plus 7 equals negative 8, and I'm going to go ahead and just use basic solving to finish this out. So my two solutions are at x equals 1 and x equals negative 15. Okay, so when we have these situations, always be checking for perfect squares in that C term. In example 2, I have some subtraction here, right? X plus 2 minus 4x plus 4 equals 16. Again, looking at that C term, it is a perfect square. So what multiplies to positive 4, but adds to negative 4? That would be negative 2 and negative 2. So I have x minus 2 times x minus 2 equals 16. I can simplify that then to x minus 2 squared equals 16. When solving, now I can take the square root of both sides. I get x minus 2 equals plus or minus 4. So x minus 2 equals 4. And I get x minus 2 equals negative 4. So as I work to solve, I add 2 to both sides. I get x equals 6 and x equals negative 2. So that is some examples of perfect square trinomial factoring. We are now going to take this a step further and use a strategy called completing the square. So if a trinomial is not a perfect square, you can turn it into one by writing it into the form of x squared plus b times x equals c, and choosing the right number to add to both sides of the equation. To pick the right value to add to both sides of the equation, take 1/2 of the b value and square it. This will make the left side of the equation a perfect square trinomial. Then you can solve the equation using the square root property. So it's just another factoring tool. So here I have x squared plus 4x minus 12 equals 0, right? So if I want to use perfect square factoring, I can move this 12, this subtract 12, to the other side. Right? This would give me x squared plus 4x equals 12. And notice I left a gap here because in my normal trinomial, I would have some sort of c value that I would want there. And I need to decide what I want to use as a c value. And the note on the previous slide said I take this b value and I divide it by 2, and then I square it. Right? So 4 divided by 2 is 2. 2 squared is 4. Right? So I want to add a 4 here. That makes the left side of this equation a perfect square. And then just with that concept of if I added 4 to one side of an equation, I have to add 4 to the other side of the equation. Right? So I'm going to simplify the right side. 12 plus 4, 16. And now I have a perfect square on the left side. X squared plus 4x plus 4. You may not write down that step because you may notice right here I can factor this by saying x plus 2 squared, right? Because that was our goal all along, was to make this a perfect square on the left side. So I have x plus 2 all squared equals 16. If I square root both sides, right, I'm going to end up with x plus 2 equals plus or minus 4. To solve that, x plus 2 equals 4. X plus 2 equals negative 4. And then I work to solve, right? I would subtract 2 from both sides. So I get x equals 2 and x equals negative 6. For example 4, we're going to have an imaginary solution here. So not knowing that piece of information, that imaginary solution, right, you would attack this the same way. Right? I want to use perfect square factoring. So I am going to subtract this 11 off to the other side. Right? So I would get x squared plus 4x equals negative 11. Notice I left that gap because I want to put something, I want to put a number here so that this is a perfect square. So I could factor out, I could take out this 4, this b value, divide it by 2, and square it. Right? So 4 divided by 2 is 2. 2 squared is 4. So I'm going to add a 4 to both sides. So working this through, simplifying, of negative 11 plus 4 is negative 7. I get x squared plus 4x plus 4. So I am now going to work to factor this using perfect square factoring. I know this is going to be x plus 2. Come on. Squared equals negative 7. As I work through and I square root both sides, right, I would get to x plus 2 equals square root of negative 7. And I have to isolate x still. So I can say x equals negative 2 plus or minus square root of negative 7. Okay, the true final answer, you can simplify this square root of negative 7 using the concept of imaginary numbers from lesson 3.2. Right? I would factor out the negative 1, right? Because we learned in our previous lesson that the square root of negative 1 is I. Square root of 7 is going to stay as just as square root of 7 because there is no simplifying that. So that should prepare you for your 3.3 assignment.